Hello, my name is Sasini. This is my natural language processing assignment 2 demonstration. So before demonstrating the system, I first confirm that that my system is running offline. So you can see the Wi-Fi is turned off, uh, and no cloud API or internet connection is used during the execution. The systems runs locally using Olama for LLM inference, files for retrieval, RDF lib for ontology processing, and streamlit for the user interface. This system confirms that the system has zero internet dependency during the runtime. So let's run the system. So my system is called HelaScore. It is an offline intelligent Sinhala history answer scorer developed for natural language processing individual assignment. The selected scope is Colonial Sri Lanka, covering the Portuguese, Dutch, and British periods. The system is not a general chatbot. It is an answer scoring system. A student selects, you can see, there are 5 questions. A student selects one of five of these predefined Sinhala history questions, and they can write answer in Sinhala, and the system grades it out of 20 marks using a structured marking guide. So this is the marking guide. So let's move to the project structure and architecture of my system. So the project follows a layered architecture actually. The presentation layer is Streamlit UI. As you can see, this is the Streamlit UI. In the app.py, this is the app.py. The agent layer contains 4 agents in here. The agent layer contains 4 agents. Retrieval agent, and scoring agent .py, ontology agent, and explanation agent. So the data and inference layer contains the data and inference layer. The data and inference layer contains the local Sinhala knowledge base. The 5 vector index and the RDF ontology, Olama running the Gemma 3 4B model. This separation makes the system modular, explainable, and easier to debug. So yeah, this is my Olama client.py, and this is my config.py. Okay, this is the rag embedded.py and retriever.py. So yeah, discussing about the knowledge base and questions. So the knowledge base contains Sinhala UTF-8 history files organized by colonial era. These files are the local evidence sources for the rag system. Here, for example, Dutch. Here, for the example, Dutch economic system file contains Sinhala historical content about the cinnamon trade, VOC, Tombu records, taxation, and long-term economic impacts. The question file contains 5 predefined Sinhala questions. Each question has 4 marking criteria, with each criterion worth 5 marks, given total 20 marks. So moving on to the RAG implementation. So the RAG pipeline grounds scoring in local historical evidence. First, the embedder reads the Sinhala knowledge base, splits into chunks, create embeddings using the multilingual mini LM, sentence transform model and stores the vectors in FICE index. At scoring time, the retriever uses the selected question and the student answer to find the top relevant Sinhala evidence passages. This reduces the hallucination because the scoring process is grounded in local knowledge-based content. So moving on to the ontology implementation. The ontology represents important colonial history concepts and relationships using RDF turtle format. It includes colonial power. It includes colonial power, legal system, economic systems, political events, religious events, and social impacts. The ontology agent loads this graph and checks whether the student answer contains expected concepts. So for the Dutch economics, yeah. For the Dutch economic question, concepts such as cinnamon trade, VOC, Mahabadde, Tombu registers, taxation, and Hamilton Canal can be detected and shown in the final output. So let's test our system. So you can see if I refresh this file, this is going offline. Yeah, our system is still offline. So I am going to choose the economic system of the Dutch, the second question. So yeah, I will, here are the criterions, 5 criteria. That's the mark, which is marks are allocated. So I am now testing a strong answer. This is my first test case. Now let's see how it turns out. So this is the demonstration of the main scoring workflow using the Dutch economic system questions. So let's it take quite a while. So you can see the system is running completely offline. So here are the results. So the question mark is marked out of 20, the 20 out of 20 using four criteria. Yeah. Here are the 4 criteria that the marks were allocated. Dutch commercial aims, cinnamon monopoly, labor and Mahabaddi systems, Tombu records and taxation and long-term economic impacts. So here are the answers there. This answer is a really good answer, really great answer actually. It got 20 out of 20. Yeah, the scorecard shows that the total mark and the performance level. The breakdown tables shows the mark awarded for each criterion. So yeah, here are the reasons why such mark is allocated. And this is the entire report, and here are the concepts of RAG, what files it used to generate this report. But actually this is important because the system does not give only one general mark, it gives a criterion level explanation. So each criterion includes a single reason explaining what the answer covered and what was missing. These explanations are generated after validation, so the final total and the reason remain consistent. Yeah. Yeah. Here we have these. Here we have the evidence passages retrieved from the local knowledge base. The retrieval agent selected these Sinhala passages from files such as uh, Dutch economic system txt and Dutch administration txt. This proves that RAG is used meaningfully in the scoring process. So the ontology section shows the matched historical concepts. For this answer, the system identifies concepts uh, such as cinnamon trade, labor system, Mahapatte, Tombu registers, cinnamon peelers, Dutch era, Hamilton Canal. So yeah, finally the explanation agent produces the complete single explanation, including the final score and the criterion breakdown, retrieved evidence source, and ontology concepts analysis. So let's try a weak answer. Weak, yeah. Let's try a medium answer, then a weak answer. As you can see, again I'm telling that this system is running offline. The answer is getting marked here. Yeah, you can see that this is an average answer, as I said, and there it has given a summary of what criterion it satisfied and what criterion it didn't satisfy that much. So here are the complete report. Let's try the weak answer. Try a weak answer. Let's see if my system detects this as a weak answer. And what mark will my system allocate for an answer like this? Because it's obviously a weak answer. But let's see what my system decide. Yeah, see, it detects this as weak answer and it fails. It gives a fail symbol. So the answer is vague. You can see the answer is really vague and does not explain the required economic system or long-term effects. So that's hence the lower score. And let's see the breakdown here. The system gives significantly lower score, so the breakdown shows the answer does not cover the expected marking criteria. The single reason explains what was missing, and the ontology output shows fewer relevant concept matches. This demonstrates that the system is not assigning marks randomly. So here, here is the criterion explanation. Let's try another test case. Let's try something new. This is something out of my system, out of the knowledge files and everything. So let's see how my system responds. It responds to such an answer, how it will mark an answer like this. Actually, this is an irrelevant answer. This answer is related to Sri Lanka's history, uh, but it is related to Anuradhapura period, not Dutch economic systems or anything. So here you can see uh, it is a weak answer. Uh, so yeah. Uh, yep. Therefore, it should receive very low score. Yeah, you can see the answer has received a really low score, uh, like 9 out of 20. Mm, this proves the score is checking semantic relevance to the selected questions. So, yeah, let's try a new empty or too short answer. Like, yeah, it shows that the answer is really short. We need more details, content. So, moving on to agent workflow and reliability summary. Uh, let's see. You can see in the agent scoring agent .py. To summarize the agent workflow, the retrieval agent searches files index to relevant evidence. The ontology agent matches the student answer agent are against the against RDF concepts in the colonial history ontology. The scoring agent builds a structured scoring prompt using the question, answer, and rubric, retrieved evidence and ontology matches, and sends it to Gemma 34B through Olama. To improve reliability, the rule based consistency. Yeah. To improve reliability, where is this? Yeah. To improve reliability, a rule based consistency check validates and merges the scoring output. The explanation agent then prepares the final score criterion breakdown and Sinhala explanation for the UI. So let's move on to Olama client.py. The system also includes reliability safeguards such as JSON parsing fallback, uh, Python based total recalculation, and deterministic Sinhala reason generation. These safeguards prevent malformed LLM output from breaking the Streamlit interface. So, in conclusion, HelaScore is a fully offline Sinhala open-ended answer scoring system for colonial Sri Lankan history. It uses Olama local inference, files-based RAG, and RDF ontology. And for agent architecture, it uses 4 agents. So it produces marks out of 20 criterion wise Sinhala explanation, retrieved evidence, ontology concepts matches, and a clear streamlit interfaces. So here you can see, even we can see the sessions. Let's input something. we can see the session history related to the questions we did. Let's wait till this comes. Yeah, in here you can see this session history. So thank you for watching. Good night.